So we have two kinds of questions, very similar to those given to you on the AP exam for the multiple choice portion. The first question, what elements of the following array would be visited if we were using binary search to look for a target of 7? This idea of visited is what we'll be exploring. Those were the numbers that would be guessed in the process of following a binary search. So here's your sorted list. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And of course they have it be even indexed. So it makes the middle like a area you could get confused on. And then a related question, for this target and this array, is binary search faster or is linear search faster? And that can be determined by how many numbers each of those algorithms visit, right? How many checks do you have to do? How many comparisons? Okay, so let's get started in reviewing it. Hopefully you had some individual time to think it over and you have an answer formulated in your head while we were waiting for people to connect. So first off, the first iteration, the first check between your when using binary search goes into the middle. So you have a high value of 9, you have a low value of 0. 4 plus 9 divided by 2, if we're following integer division, gets you to 4, right? Positions 4 and 5 are the middle, you go for the lower one. So we guess position 4. We have visited 11. Since we're looking for 7, 11 is bigger than 7, so that means we eliminate all these numbers over here. So far, we've just visited 11. Now we got to do some updating. Notice that once we've done that comparison, 11's too big. We change our guess, or we change our high to be guess minus 1. Our upper bound, our high value is now 3. 0 plus 3 gets you to, divided by 2 gets you to 1. We guess position 1. We have now visited the value 3, 2 numbers. 3 compared to 7, it's way too small compared to our target. Thus, we update our low value to be 1 more than our guess, so then it becomes 2. Again, we check the middle. 2 plus 3 divided by 2, that equals 2. We check position 2. We have now found 4. 4 is still too small, so yet again we update our low to be 1 bigger than our guess. We visited 3 numbers so far. Now, we do this final comparison. It still checks. High plus low divided by 2, it's position 3, so we guess 3. 3 is 7, nice. We've visited 4 numbers in total. Here is a little animation that illustrates that process, right? Notice visited is the same as clicking on those numbers that become white and highlighted. Those are our guesses. It took 4 guesses to get to our 7 in this array. So part 2 is linear search faster. Well, if you did linear search and you're looking for 7, you'd check 0, check 3, check 4, check 7. There are 4 numbers that are visited with linear search. And if we're looking at like speed, I guess, that's pretty much like it's tied for this specific array. If it asks you in general, it depends, like on average binary search would be better, but in some cases linear search is faster. If like your element is the very first thing, you would get it. Versus binary search does a bunch of jumping around to arrive there. It's actually slower for if it happens to be that smallest number you're looking for. So let's go through that same kind of idea, right, now on your own. How many elements would be visited if you're looking for 27 in this array? And then I'll annotate to the screen and kind of go through that process. Take a minute or so, think about this on your own, and we'll talk about it. Forgot to turn back on my recording, so We reviewed this problem. It's likely that people messed up on updating the high indexed after they guessed 30, right? So we're split between the 3 and 4 elements being checked. The answer here is 3, and you should watch the last number that you check. It's that guess -1 and guess +1 idea that's throwing us off. Okay, on to words count. So if we're working with strings, yeah, and let's say it's been a while. Oh, I forgot my string functions. Is it size or is it length? How do I find the length of a string? That seems to be useful for this one. You should have handy, and if you print it out, there's a quick reference guide that you're allowed on the AP exam. And in the quick reference guide, this tells you all the functions you should know and should use for that AP exam. So for me, if I'm like lost and like, I forgot if it was size or length, look, right there. With regards to strings, it gives you use.length with the little function parentheses there. It reminds me that, that's what I need to use. What the heck? I feel like things are missing in this one. But you should have this handy. If you have a printer, I would recommend printing it out. If you want to save it as a PDF somewhere to keep it handy, I would do that too. Okay, so given an array of strings, return the count of the number of strings with a given length. Yep, that came in handy. So in this case, I have, on the AP exam, they also give you a couple of examples to get you going. Understand the examples. I'm looking for arrays of size 1, so that's A and B, which is why it returns 2. 3, so I'm looking inside this array of 4 strings. It gives me 3 things. I'm looking for strings of length 3, so there's only one of those. 4, there are none. It seems like, although it didn't say, these numbers here could be 0, right? Those are edge cases. What happens if your array is empty? What happens if your length is 0? Those are kind of test cases that aren't shown to you, but your code should address. And you betcha that the FRQ rubric would have something that addresses like 0 or null or those kinds of things. Right. So in my function, I have my array that's called words, nice, and then length. I'm going to resist wanting to press go, but still good practice is like you get a point for doing like int answer equals 0 and then returning answer. So something like this gets you like one of the points. You have the correct return type that's present, guaranteed. That's an easy point to get on an FRQ. You can do that if you're writing it out by hand by writing, declaring a variable and returning it at the very end, leaving plenty of space for some other bits of code. Online, type something out like this. They don't care about spacing. Okay, next. What's up? So, for sure, if I'm like thinking this through, I need a loop to process each, or let's use the word visit, right? Like with searching. Visit each string in my array. Right, that's one part that I'm pretty sure I gotta use. And then I need to check if the length of that string is equal to length. If so, then I need to update my answer variable. Then at the end, I return it. So 3 little notes to myself on what I need to do. I think I've addressed all components. Let's see. So let's begin writing some code. And that thing. Do I handle an empty array of strings or when length equals 0? So that was something I mentioned before, edge cases. Make myself a little note that hopefully is addressed in my code, and if not, I gotta add in that bit. Int I equals 0, I less than words.length. Ooh. So this one, if you have forgotten how to figure out the length of an array, that would also be a good point to go into the quick reference guide. Does it show me? I feel like there's stuff that's not loaded. Where is it? Array list. So array list uses size, so I'm pretty sure it uses length with no parentheses. They do give you some wiggle room with like syntax. So if this happened to be wrong, then your grader wouldn't count it against you because the idea is like fine. All right, next part, my second comment. I have to check. All right, words I, words square bracket I. That gets me my string. I'm checking this string's length, and because I'm working with a string, this length needs those parentheses being there. Does that equal my desired length? If so, answer equals answer plus 1. Okay, alternatively, you could have done answer plus plus. Now, onto my comment. If I want to make some of my own test cases, I don't like the pink color. What happens if my array looked like this? If it was empty and I wanted to find strings of length 5, for example, what happens if that was my input? Let's see if my code would still work. My length of my array here, words.length is 0. Okay, so my loop would it run? Yeah, it would not run, so then I return 0. Great. As expected, if you have an empty list, you can't check of any length. Great. Let's walk through my code with this test case, right? If my words.length is 4, okay, 4, I have to do 4 checks, okay, words square bracket I, okay, start at 0, A is not equal to 4, so don't grow, nice. Go to B, and then B is not equal to 4, so we don't increment, great, answer stays 0, nice. So on and so forth, okay, cool. I think I'm ready to press run, right? And at this point, this is like my final draft. Let's see, how'd I do? Oh, nice, I got it all correct. So, sorry, I forgot we use length. Right, so here's a rule of thumb. For arrays, they are they're built in. Think about them as like a primitive. When you're working with member functions, right, it belongs to something. A words I is a member of the string class. Thus, if you're accessing a member function, you must have these parentheses being there. An array list, it also happens to be a class. That's why size requires those little parentheses being there. Arrays don't because it's a built-in data type, but there aren't. Well, I think there might be an array object in Java, but we're not particularly using that. So that's why you can leave off the parentheses here, if that helps. Okay, on to the next one. Again, let me model that process I want you to step through. Try not to press go too soon to have that first take on like a fresh FRQ on how you would approach it. This problem is related to the one we started yesterday, where we recursively went through a list of strings. But this case, we're working with array lists, and it's been a while since we worked with those. Again, let's reference this thing, the quick reference guide. Scroll down a bit, and it tells you the useful functions you need to know when working with array lists. And maybe for ease, did it save my answer from last week? Maybe I can copy and paste some things over and... Nope, I didn't save it. Okay, I didn't sign in either. So it looks like we have to recreate our code that we wrote yesterday. But now using array lists. So we're looking for milk. We have to go through base case and recursive bit. I think on the actual AP test, you won't be expected to write recursion. Don't quote me on that. I gotta check with Mr. Simon. Likely it'll show up in the multiple choice section, but I don't think it will challenge you in this way. But for us in practice and understanding, we will for this class because we're better than the AP exam. All right, so where do we start? Need a base case. Base case has to deal with I compared to the length of the array list. And then here's the recursive stuff. Okay. So if I remember from yesterday, we have to address when strings, this array list, when its size is equal to 0, for sure I return false, right? If your strings.size, okay, just building off what I was doing yesterday is what I remember. I have to do a comparison. I have to access particular, a particular element of an array list. So I can't use square brackets, right? That's for arrays. For array lists, to access certain elements, I have to, let's see, I want the object that's there. So this one returns the position, returns element at position index. Nice. This thing returns an object. So I want to use get instead of square brackets with array lists. So go here. If I want to dot get position 0, right, that thing, this whole string, we have to check whether or not it equals the word milk. Okay, so this part returns, like it checks and gets this word water. Then with this string water, we're comparing that to milk. Notice with string comparisons, we don't use double equals. That does some memory and pointer comparisons, which we don't want to do. We want to check the values present in those strings. All right, next up, what do I remember from yesterday? We did a test case where I, when it's bigger than or equal to strings.size, we have effectively gone through our entire array and milk was not there, so we have to return false. Checked everything in list and milk is not there. Then, from yesterday, the recursive stuff. If I, this kind of works like a counter, like it does in loop, when it is bigger than or equal to 2, we have to return, that was a big point that I forgot yesterday, return recursive call, so gotMilkList, and then we do something funny with the arguments. We have to grow our index, comma, same array list, I think. Is that all? I think so. Let's step through, okay, this test case with the code that I've written. Let's see if it handles it correctly. So in this test case, the array of my strings is the size of my list is 3, and I'm looking for the word milk. So at first, I do water, soda, juice. Great. I right now is 0. Strings remains unchanged. So 0. Oh shoot, did I mess something up? Sorry, I don't think it should be I here. Should it be I? Right, because now as my code is written, 0 is not bigger than my size. The size is not 0, so we don't check that. Size is not 1, so we don't go there. And then I is not bigger than equal to 2. Uh-oh. Right? Our case doesn't even handle this one correctly. Looks like I messed up with one of my if statements. Good thing I'm checking over with the predetermined test cases. Anyone have some suggestions? I think this should be, something's not right. Yeah, right. This one, my recursive stuff, it should be based on the size, not I. One sec. yeah, let's see what happens now. Okay, we made a little change. Let's go through this test case again. Right now, I is 0. Don't go here, don't do that, not yet, not yet. So now my string is 3. 3 is bigger than 2. So now we go recursively call this one. In this iteration, I equals 1. Then we check. Okay, I is not bigger than my size. Size is not 0, not this. So then we go here. Uh-oh. So when we go here, I is 1, size is still bigger than 2, and then we go I equals 2. Nuts. Yet we didn't do any comparisons. I'm worried here. So then I is equal to 2. 2 is not bigger than our size. We go down here, we recurse. I is now equal to 3. And then 3 is bigger than our size. So then we stop, we return false. Okay. Alright, so for that test case, that seemed fine. Let's check to see if when the word is actually in my array. Let's see if it handles this test case. Erase. Starting over. I'm modeling the process that I hope you all will be taking to get the most out of these FRQs. Double check the time. I've ran out of time. So the last 5 minutes, I'll talk through for the video's sake. You guys should get going though. It is 12:30. You're welcome to stay a couple minutes, but I don't want to hold you since block 6 is officially over. Okay, so I'm walking through this test case where there are 4 things. My size is 4. I start at 0. Okay, I being 0. I skip this one, okay, and then size is not this one, not this one. I go strings.size, yep, it's 4, so I do go down here, and I check, okay, I recurse. Got milk, I plus 1. 0 plus 1 gets me to 1, so then for this recursive call, I think this code is like wrong. We're not doing something with I that we should be doing, right? We should be doing a comparison based on I somewhere in here. Because I think you'll see in this test case, I should have found milk, but it instead keeps recursing until I is bigger than size and then returns false. So something's wrong in our code. We need to make better use of I and check. So let me erase. Let's me think. So our recursion seems a little bit off now. When my size is bigger than 2, I should be checking. I have to check position I, right? Yeah, I think I'm missing like a check here. If my strings dot get at position I dot equals milk is true, then we return true, right? We found our we found milk. Otherwise, we keep recursing. We haven't found milk just yet, so we must keep recursing. So for the video's purposes and for those that are staying by your own choice, I think this should address it. So again, we'll walk through this test case. Our length is 4 of our array list, and currently I equals 0. So we don't go here, don't go here. don't go here. Size is bigger than 2, so we're here. If our strings.get, oops, look at my mistake, I use square brackets when it should be parentheses. Same here, I made that mistake because it's a function. So I get position 0. It is the word milk. Milk does equal milk. Nice. So I return true. Let's try this test case now and make sure that I actually go down to that position. Let me clear up my annotations for the recording purposes. Okay, same length, but now start over. I equals 0. So we go down here, check. Does it equal milk? Nope. So we go down to our else statement. We recurse, and now I equals 1. We check, okay? We're still here. Does this one equal milk? Nope. So we recurse again. I equals 2. 1 equals 2. Is position 2 equal to 0? Equal to milk? Nope. So we return we recurse yet again. I equals 3. And now when we got down here, position 3, is that word equal to milk? Yes, it is. So we return true. Let's say this thing was not milk. What happens if position 3 was t? In this case, in this 4-length array list, the word milk was not there. So we go ahead and recurse once more, and it ends up being false. And then this is the test case that catches milk not being there. I'm confident now. Let me try to press go. Let's see. Uh-oh, I missed a return statement at the very end. That's a coding bad thing. And we got it all correct. Cool. Thanks for staying. That's all for today. Hope it's